Understanding the grounding requirements for generators according to the National Electrical Code, specifically Section 250.30A, is crucial for electrical safety. The code mandates that the frame and external electrically conductive parts of a generator be properly grounded, although the specific wording connected to an approved earth ground might not appear verbatim. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock and fire hazards. Section 250.30 addresses the grounding requirements for separately derived systems, which includes generators. A separately derived system is an electrical system that derives its power from a source other than the service, such as a generator, transformer, or converter. When a generator operates as a separately derived system, it needs to be grounded in accordance with the NEC to ensure electrical safety. The grounding requirements in Section 250.30 outline how to properly ground the generator frame and other conductive parts. Firstly, the generator frame must be connected to a grounding electrode system. This electrode system can consist of various grounding electrodes, such as a ground rod, ground ring, or connection to a metallic water pipe. The selection of the grounding electrode system depends on the specific conditions at the installation site and must comply with the requirements outlined in Article 250 of the NEC. Secondly, a grounding electrode conductor must connect the generator frame to the grounding electrode system. The size of the grounding electrode conductor is determined by the size of the generator's conductors in accordance with NEC Table 250.66. It's essential to use the correct size conductor to ensure that it can safely carry any fault current that may occur. Thirdly, the NEC requires that the neutral conductor of the generator, if one exists, be bonded to the generator frame. This bonding ensures that the neutral conductor is at the same potential as the generator frame, which helps to prevent voltage differences that could create a shock hazard. The bonding connection must be made at the generator, and the bonding conductor must be sized according to NEC Table 250.102 cone. Fourthly, all external electrically conductive parts of the generator, such as the enclosure, conduit, and other metallic components, must be connected to the grounding system. This ensures that these parts are at the same potential as the generator frame, which minimizes the risk of electrical shock. The grounding connections must be made using approved methods such as grounding bushings, bonding jumpers, or other suitable fittings. Fifthly, it's essential to follow the manufacturer's instructions for grounding the generator. The manufacturer may have specific recommendations or requirements that must be followed to ensure safe and reliable operation. These instructions may include details on the location of grounding points, the type of grounding conductors to use, and any other specific considerations. Proper grounding of a generator is not only a safety requirement but also helps to ensure the reliable operation of the generator and any equipment connected to it. A properly grounded generator can help to prevent voltage fluctuations, reduce electrical noise, and minimize the risk of damage to sensitive electronic equipment. It's important to note that the NEC provides minimum requirements for grounding generators, and it may be necessary to exceed these requirements in certain situations. For example, if the generator is located in an area with high soil resistivity, it may be necessary to install additional grounding electrodes to ensure adequate grounding. Additionally, it's important to consult with a qualified electrician or electrical engineer to ensure that the generator is grounded in accordance with all applicable codes and standards. This is particularly important for complex installations or in situations where there are specific concerns about electrical safety. The requirements outlined in Section 250.30 are intended to provide a safe and effective means of grounding generators, but it's essential to understand the underlying principles and to apply them correctly in each specific situation. By following the NEC guidelines and consulting with qualified professionals, it's possible to ensure the generators are grounded in a way that protects people and property from electrical hazards. In summary, the NEC mandates proper grounding of generator frames and external conductive parts to ensure electrical safety. Section 250.30a specifically addresses grounding requirements for separately derived systems like generators. Key aspects include connecting the frame to a grounding electrode system, using appropriately sized grounding electrode conductors, bonding the neutral conductor to the frame if applicable, and grounding all external conductive parts. Following manufacturer instructions and consulting with qualified professionals are also crucial for ensuring compliance and safety. Proper grounding prevents shock hazards, facilitates the operation of overcurrent devices, and helps maintain stable voltage, protecting both people and equipment. Furthermore, understanding the specific context of the generator installation is vital. Factors such as soil resistivity may necessitate exceeding the minimum requirements outlined in the NEC. Seeking expert advice ensures that the grounding system is tailored to the specific needs of the installation, promoting a safe and reliable electrical system. By adhering to these principles and guidelines, one can confidently establish a safe and compliant grounding system for generators, minimizing the risk of electrical hazards and ensuring the reliable operation of connected equipment. This thorough approach underscores the importance of knowledge, careful planning, and professional execution in all aspects of electrical work, particularly when dealing with potentially hazardous equipment like generators. Always prioritize safety and consult with qualified experts to ensure that the electrical system meets all applicable codes and standards.